So yes, guys. So welcome everybody to today's webinar. Today we are privileged to be having Marcrine with us. We'll be sharing with us a solution on how to configure and deploy a 3-tier AWS architecture using an IaC tool, which is Terraform. So she will tell us more about it and also introduce herself while at it. So I hope, Marcrine, you are ready. I'm going to hand over the screen to you in a minute. Let me just change something. Going to hand over the screen to you just now. All right, Marcrine.
Patrick.
Yes.
Oh, yes. Can you see my screen?
Yes, I can. We can. It's still loading.
Okay. Oh. Can you see my VS Code?
Not yet, but it's loading. At least we can see your teams.
Okay.
Yes, we can now see your VS Code.
Oh. Okay.
Is there a way of making it a bit larger?
Oh. So okay. That's okay. Better.
No, I think it's okay. Maybe you can just continue. I'd advise guys who are following us, maybe you can try and maximize your screens from where you are so that you'll be able to see the code. So Marcrine, carry on.
Okay, just a minute. Yes. Oh, Patrick, should I introduce myself or should I just...
Yes. There are so many people here who don't know you.
Okay. Okay, I'm Marcrine Musimbi. Yes, and I'll be teaching you something today. Terraform. Yeah. I think that's enough for today, the introduction. So I'll continue. I'll start.
Awesome.
So, yeah, okay. Terraform is an infrastructure as code tool. We use it to deploy services in the cloud. You can choose to deploy in AWS or Google Cloud or Azure. But today, we're going to deploy it in AWS. And I'll just show you the image you're going to deploy. Yeah. Just a minute. Yeah, here it is. I hope you can see the image, the architecture that you're going to deploy.
Yes, we can.
Using Terraform. Yeah. So we're supposed to deploy VPC, 2 AZs, okay, in 2 AZs, internet gateway, NAT gateway, public subnets, private subnets, and databases, and these EC2 instances, security groups, auto-scaling groups, load balancers, specifically, okay, application load balancers, 2 of them, one for the front end and one for the back end. So to start with Terraform, for beginners, you have to, if you're using AWS, it's advisable not to use the root user. So you'll have to create an IAM user, and then you'll get the credentials for this user, the access key and the secret key, which you'll integrate it with your VS Code, okay, with your machine, using the command, or okay, AWS configure. We use this command to input the credentials of the IAM user, so that you can, when you deploy services, you're using that user, the IAM user you've created. Yes. And then to learn Terraform, okay, there's a lot of resources in AWS, and Terraform has their documentation. You can go through it And as you can see, there are many resources here, like network ACLs. They're called NACLs. You can see route table, and they explain everything, like literally everything, every code. So you can use this to learn. VPC, you can see here, this is a default VPC. So I'll go straight into my code. So we are deploying this architecture right here. So yes, first you need to install Terraform, and it's good to have this extension, the AWS extension and the Terraform extension. So first, you should always define which provider you are using. In this case, you are using AWS. And you can see the format, the Terraform format. This is the only format you can use for Terraform. It's not like CloudFormation, where you can use JSON or YAML. For Terraform, you just use this format, Terraform format. So first, define your provider, AWS, and then, okay, before I go into the code, I'd like you to see my structure. It's advisable not to put the code in one file, because it will be a lot of lines, and it will be hard to debug. So you have to divide it. You can see here, I've divided it into, there is a VPC file, security group for EC2. There is a load balancer for front-end and back-end, and there is a security group for the load balancers. There is a launch configurations files, and there is this user data, both for back-end and front-end. Yeah. So I'll start with the main. We're starting from the top of the image. So you define AWS, there it is, and then you create VPC. And it's good to put comments on your code. Like, it's very important, so that when you get back to it, you can understand what you're doing. So for VPC, you can see I have defined here VPC. The name of my VPC is CloudForce VPC. Okay, underscore VPC. You should also know the naming system of resources in AWS. You just don't name things the way you are used to naming it, because you can't do that with a space. You have to put like an underscore or a dash. Yes. And this is the CIDR block for my VPC. I chose this CIDR block. I hope everyone knows what CIDR block is, but yeah, we'll talk more about that. And the tag name is CloudForce VPC. That's the code for VPC. And then for subnets, I created a public subnet 1, private subnet 1, and public subnet 2, and private subnet 2. So for public subnet 1, this is public A. It's where our web server will be, like the presentation server. Yes, where users will be interacting with our web application. So this public subnet has a CIDR block of this /24. It has to be smaller than the main CIDR block of the VPC. So this one is /24, and it's a .1, as you can see there, and it's in the availability zone A, US East 1A. I chose that to be my default. Okay, it's my default region, so I chose to go with that. And then private subnet A has a CIDR block of /24, and it's in 2. And then public subnet 2 is in 3 and 4. Like, okay, they cannot be the same. You have to put them in different. Yeah. So after creating the VPC subnets, next you go to the internet gateway. The internet gateway will allow our instances to interact with the internet, just as it is the internet gateway. So I named our internet gateway CloudForce IGW, and these are the only things you need: the VPC ID, where it will be in each VPC, and you give it a name. And next, you create a route table. That is where you will put your routes, where your traffic will go through, where, the destination, the sources, and you connect everything there. After creating the route table, this code here. I hope you can see my code clearly. I don't know if you can see it clearly, but
Yes,
okay.
it is
Patrick.
visible. It is
Yeah,
visible.
okay.
And maybe
Okay,
for the
that's
participants, when she asks such questions, you can use a reaction emoji, maybe a
yeah,
hand clap or a thumbs up.
yeah. I
Okay.
cannot see the reaction, so you'll just tell me. Okay. So
Okay.
after creating a route table, you'll create a route. And for a route, you only need the route table ID, the destination CIDR block, and this CIDR block, this 000, this always means that it's going okay, it's anywhere, like everywhere, anywhere. Yeah. And you need the gateway ID, and you'll be done with creating a route. After creating a route, you associate the route table with the subnets. So you just need the subnet ID. And for here, we chose a public subnet. We're associating it with the public subnet A, and you give it a route table ID. This is an association. Okay. Association 2, you use public subnet B. And internet gateway, it's only connected to the public subnet. I hope you have noticed that. So you can't connect it to the private subnets. If you connect it to the private subnets, it will mean that they are not private anymore. They will be public. Yeah. Next, we create a NAT gateway. NAT gateway should be placed in the public subnet. As you can see in this diagram, we have a NAT gateway in the public subnet, and it's also in this public subnet. You can choose to use one NAT gateway or two. It will depend with your rules. So in this case, I created a NAT gateway, and creating a NAT gateway is very easy using Terraform, of course. Yeah, and you need an elastic IP for the NAT gateway. And now the NAT gateway should always be in the public subnet. It's always there. It will never be in the private subnet, always in the public subnet. I hope you're getting that point. It's very important. So the NAT gateway, I called mine the Cloud NAT. Yeah, okay. You can forgive my naming system. I'm really trying with names and all that. So this is our NAT gateway. I created NAT gateway 1, and you associate it to the route. You connect it to the route table. You add it there, and inside the block is anywhere. Okay, if I say anywhere, just know it's this 000. So it's anywhere, and then you associate the route table for the NAT gateway to public subnet A. You have to connect it to the public subnet so that it's there, and the private, you add private subnet to it so that it can know which private subnet it's connecting to or communicating with. So for this NAT gateway, this one is for private subnet A. You can see here. Yes, for private subnet A. And this one is for private subnet B. So I created one NAT gateway and connected it to private subnet A and private subnet B. And that's it with the VPC. Yeah, I hope you've understood everything I've said. And this, okay, to get these colors, nice colors, you need to install the Terraform extension. And you also need this AWS extension so that it can autocomplete for you some codes. Yeah. Now we're done with the VPC and the internet gateway, the NAT gateway, the association. Next, we go to the auto-scaling groups. Yes. And okay, yeah, auto-scaling groups. I'll start with the front-end auto-scaling group. An auto-scaling group, it's a service that helps you to automatically scale in and out the instances. It depends with the traffic. When the traffic is high, it will scale out. When the traffic is low, it will scale in. So this is my front-end auto-scaling group. So for this one, I chose to have a minimum of 2 instances and a maximum of 6 instances. And you have to give it a name. And yeah, you should not be scared of these codes. They are here, like they have explained everything here in their documentation. You can just go through it. Yes. Now our auto-scaling group needs a health check type. I gave it an EC2. And this is an auto-scaling group for the front end. And from the diagram, you can see the front end is for the public subnets. So this is the auto-scaling group we are creating, this one here. So the VPC zone identifier is public subnet A and public subnet B. And now the target groups, what are we targeting? We are targeting the load balancer, yes. And this is a policy for the the launch template. Before I continue, I'll just go to the load balancer first. Here it is for front end. Okay, we are in the front end. So for the load balancer, this is my load balancer. It's an application load balancer. And you should create a security group for the load balancer. And these are the subnets where the load balancer will be. And okay, what's a load balancer? A load balancer, it helps with balancing traffic between instances so that one instance is not overloaded with traffic. So it will balance traffic through all the instances, whether there are 2 or 20, it will balance the traffic evenly. And that's a good thing about load balancers. Now, the load balancers need a target group. What are they targeting? In this case, they're targeting a port. Port 80 in this case, port 80. We're targeting port 80 of the instance, the EC2 instance, where our application is. So this is the target group for our load balancer. You need to create a target group. We're targeting port 80, and port 80 is always an HTTP. If you are to choose port 443, that will be HTTPS, and other ports have port numbers too and different names. Yeah, and we need a listener. So our load balancer is listening on port 80. In case of any traffic, it will be there listening and waiting for it to come. I hope I'm explaining myself as simple as I can. Yeah. Up to
yes,
that
you
point.
guys are reacting. They are understanding.
Okay. Okay. If there is any question, you can ask. But if there is no question, you can continue. So that's a load balancer. And I hope you've noticed that these are just simple codes. And okay, it's fun to write a Terraform template instead of going to the AWS UI and creating them, searching for things. It can be tough sometimes. So I'll go to the auto-scaling group. I had explained this for the front end and our launch template. So I'll go to our launch template, and this is an auto-scaling policy. So this is just a normal policy. We are checking the CPU utilization of our instances. If the CPU usage goes high, it will add. It goes low, maybe it will reduce. Yeah, and our launch configuration. This is we need a launch template for our auto-scaling group, so that when it creates EC2 instances, it will use this template that we've created. And this template is just defining how the EC2 instance should be, the instance type. In my case, I'm using T2 micro, okay, because it's free for a few hours, 750 hours. Yeah, it's free. And you need an AMI, image ID. This is image ID for Ubuntu. I just like Ubuntu, but you can also choose Amazon Linux, you can choose Windows, you can choose any image ID you want. Yes. And the launch template, you need to create a security group for the instances, for security, of course, just as the name is. And our user data, what are we installing on our EC2 instance? You need to define that. And I placed this one in this file, frontend data.sh. It's a script actually. And I noticed that sometimes you need to add this base64 encode, because there are other articles that say maybe you can use this file only, but in my case I had to add this so that it could work. So I'll go to my user data, this file here. I had to separate them so that I can have a clean work, yeah, for just cleanliness, yes. So after the EC2 instances have been started, the first thing you should always do, you should update it so that it can install updates. And this first line is a shebang. For every script, you should always, you're supposed to use a shebang for the first line. Okay, this line is called a shebang. I hope you are understanding what I'm saying. Yeah. So it will update, and then it will install Docker. This is the code for installing Docker up to here in Ubuntu. Like it's not for every operating system. This is only for Ubuntu. And the reason why I'm using Docker is because my application is in a Docker container. That's why I use Docker, so that at least my instances can have something, so that I'm not just creating them and not testing them. That's why I use Docker. And this line here is for pulling the image from my Docker Hub. Yes. And in my Docker Hub, my image is called a bookup frontend. This is for frontend only. I created a Docker for both frontend and backend because they are different. For frontend is React, for backend is Node.js. And then this line here, this is very important. You have to run the Docker in your EC2 instance. At first, maybe you should always, not always, but it's advisable to use this port 80, port 3000. So in this case, port 3000 is where the Docker container is running, but we are mapping it to port 80 so that when our load balancer listens on port 80, it will find the Docker running so that it will give us something that you can see. Yeah. I hope you've understood up to there. If you have any questions about Docker, I'll be willing to answer. Yeah. Now that's the front end data. And we've linked it to our launch configuration here. You can see here. And you should always confirm that your naming is correct, because if you miss one letter here, everything will be an error. Now we go to security groups. I'll start with the security group for the EC2 instances. This one's here. And you can see ingress is for incoming traffic that's coming into the EC2 instance. So we'll only allow incoming traffic to port 80, and this is a TCP protocol. And we are linking it to the load balancer security group. And the CIDR blocks, okay, I chose this one anywhere. And also ingress for port 3000, though this one is not necessary. Okay, it's not important for now, this port 3000. You only need port 80. And I used port 22 because I wanted to test my instances if they have actually installed Docker or something. That's why I used port 22 to open the SSH port so that I can run in the terminal, connect from the terminal. Yeah. Outgoing traffic is called egress from the EC2. And in this case, it can go anywhere. Yeah. I hope you've understood about security groups. I really hope you are understanding me. Yes. Now we go to the load balancer security group. For the load balancer, incoming traffic still on port 80. And also egress, it will be anywhere. Outgoing, it will be anywhere. Don't mind about this port 3000. I was just doing it for testing purposes. And I think I've explained almost all my code for this part here. This part, the public subnet for front end. Yeah, we've created all this. For now, I'm going to start Terraform. So this is the most interesting part of Terraform, writing your code. But you can choose to write small codes, okay, in portions, small bits, and then test them by running them one by one. You don't have to do all of them at once. So the first command for Terraform, always Terraform init, very simple. It's just to initialize the Terraform, and it's nice running Terraform like this. The next command, you have to plan so that you see how many resources you're going to provision and just how the plan is. You always have to do the plan. And as you can see here, I'm going to deploy 29 resources, 29 to add, and you can scroll for more details. Yeah, you can see this is my VPC. It will be created and all that. They have outlined it for you there. You can go through it when you do it. And as you can see here, they're saying now you have to do Terraform apply. Terraform apply like that. That is now, it will deploy the resources, and it might take a few, maybe 1 minute or 2 minutes. And as we wait, you can ask questions. Patrick.
So, perhaps guys are wondering, from where do you get the codes to feed in the various files that you've created for Terraform?
Pardon?
I'm asking.
Yes.
Where do you get the codes that you have used in the various files that you've created for Terraform?
Oh yes. That's easy. You just have to use their documentation. Yeah, like everything is here. You can see here VPC, subnets, route table is here. You can see everything is here, like, and it's explained in details.
Perhaps you can share the link to that for guys who would like to try it on their own for later.
Let me do that right now. Yeah, you can choose it. Okay, not choose. Okay, you can use it. Any other question?
Awesome.
So, are you guys okay? I hope you are all okay.
Anybody with a question can raise their hand. You'll be given the mic to continue.
Okay, we are still waiting for it to create. They are choppies. They know everything. Leah. Is Leah around? Okay. Lewis. Steve. Are you okay? Okay. Leah, are you okay? Are you okay with Terraform?
Yes, I'm fine. Yes.
That's awesome. Okay. Yes. And everyone who is here, I hope you are understanding. Mark. Is
Yeah,
Mark around?
amazing session. We are enjoying.
Oh, that's awesome. Yes. Now you can. Okay, still creating. Yeah, complete. Now, if you see
Awesome.
anything green, if you see anything green, just know it's successful.
Awesome.
And now we go to our AWS to confirm if everything is working. Now this is the most scary part. Okay, it's not scary, but okay, yeah. Now if we go to our EC2 instances, we want to see if they are running. Give it a second. Okay, yeah, there. I'll just change this to running so that you can only see the running instances. You can see, and you can see here, this instance is in US East 1A. This one is in US East 1B. This one is in US East 1A. They're still initializing. We have to wait for the checks to complete. As we wait, you can ask anything. Feel free to ask anything.
Yes, we have Kelvin with a question.
Okay. Go ahead, Kelvin.
Hi, Musimbi.
Hi.
I wanted to ask, is it the same with CloudFormation?
Okay, for CloudFormation, you have to come to AWS, okay, the UI, and upload the template you've created. But for Terraform, you just have to do Terraform init, Terraform plan, and apply.
Oh, okay.
Yeah, yes, that easy. It's that easy. It's
Okay.
awesome.
Thanks.
Yeah. You can see our 2 instances have completed the checks. And
Yes, Marcrine, we
yes,
have another
go ahead.
question from Hillary. Hillary?
Patrick.
Hey, Marcrine.
Hi,
Hey,
Hillary,
Marcrine.
continue.
Okay.
I was asking the same can be replicated using another cloud provider, let's say Azure.
Oh, for Azure. Oh, you're saying it can be replicated.
I'm asking if it can be replicated.
Okay, they all have different formats. Like for AWS, the services are named differently compared to Azure. So for Azure, you have to do it differently, not the same way, but the code format will always be .tf. But now you'll have to name it the resources. Like, okay, if we come here to the code, you can see here, like these resources, everything starts with AWS_security group. Here, AWS_route. Now for Azure, it will be different. And some services are named differently in Azure. Okay, they are all different, but they do the same thing, but they are named differently. Have you understood? Have you understand?
Yeah, thank you.
Okay. Awesome. Any more questions? No questions?
Okay, Marcrine.
Yes?
I think it's also important to remind us that CloudFormation is AWS based, while Terraform is an IaC that is open source. So you can use it with any cloud provider, just following a different format as you've just explained.
Yeah, that's awesome. I hope everyone has heard that. That's okay. I hope everyone is enjoying this, because you need to enjoy this. We all have to. Yeah. All the checks have passed, and it's still, yeah, putting up instances and all that. Now we go to our load balancer. We want to test them. They are all active. And before that, you have to check your target groups to check if you have healthy instances, because if there are no healthy instances, it won't work. So fingers crossed. Yeah, now we have 2 healthy instances for the front end. We are testing the front end. and we have 0 unhealthy. So that's a good sign. So we're going to test our front-end load balancer here. You just have to copy the DNS name and open a new tab and paste it there. Wait for it to load. Yeah, and there it is. My beautiful application. Yeah, for the front end. This means that it's working. This is a React page. It's just a simple application for nerds. You can choose any book. Yeah, that means the front end is working. And any questions? Any questions? I think I'm done for today's session. Patrick.
All right, we have a question from Mark.
Yeah, Mark, go ahead.
Okay, first of all, thank you. Insightful session. We're learning a lot. And I just wanted to ask, is there a way you can destroy these instances?
Yeah, yes.
Okay.
Very simple. Now I just have to write Terraform destroy. It's a beautiful thing, huh? Yeah. Now we are destroying everything. We destroy.
Yeah, saying it's
Very
beautiful to
fast.
destroy.
Yeah, like okay. Now you won't forget anything, because if you don't use Terraform, you might forget to destroy a NAT gateway, and it's charged a lot of cash. Now if you just do Terraform destroy, it will destroy everything, and our account will be clean, very clean. Now wait for it to destroy. As you wait, you can ask anything. Anyone with a question?
Okay.
Patrick, are you talking?
No, it's not me. So I think yes, Delphi.
Yes, I have a question.
Yes.
Yes, so there you have said that when you want to destroy the resources that you have created, you just run Terraform destroy. So doesn't specify the specific resources that you want to destroy, or will destroy all the resources that you ever created on your account using Terraform?
Okay, it will destroy only the resources that I've deployed in this folder, because okay, I'm currently in this folder. Let me open another terminal. Okay, just wait a second. Yeah, it has completed. Now you can see where I'm running my commands in this folder, projects 3-tier. So this is where I've been doing the Terraform init, Terraform plan, apply in this directory. So it will only destroy the resources that are in this directory.
Okay. Then
Yeah.
I have another question.
Yes.
First, sorry, I was late. I was not there when you were starting. So when you just CD into that folder that you are in right now, did you bootstrap first so that, or to just go into the folder and start without bootstrapping?
Okay. First, you have to make sure you have created, you've installed Terraform. You need its extension. You need to configure the credentials for the IAM user before anything. And you can only run the Terraform commands where there is a Terraform file. And if I decide to put these files in folders, I have to get into that folder so that I can run the Terraform in it for it to create those resources. Yes?
Okay, thank you.
Welcome.
Yes,
now
Kelvin.
we've destroyed. Okay. Kelvin?
So I wanted to ask, now that it's very easy to destroy your resources, how do you protect your EC2 instances from accidental deletion? I'm sorry, I might have missed your. I came in late. I might have missed when you were explaining. So I wanted to know, how do you protect maybe your EC2s from accidental deletion now that destroying your resources is one click away?
Okay. Okay, what I know is that when you want to protect your EC2 instances, there is this, I'll just use this one here. You can see I've terminated everything. We're going to try to launch an instance. There is there is that termination protection in the advanced details. Here, termination protection. You can enable it when you're creating EC2 instances, so that when you want to destroy, it will ask you first, do you want to destroy? You say yes or no. Yeah.
Okay, so it can't be done on the template.
Yes, you can do anything. You can do anything with code. Yes, and you can see I've destroyed everything. You can check here. There is nothing. Load balancers. There are no load balancers. Everything is clean, new. Yes, nothing. Now you can ask your questions. I think I'm done. And we'll do backend next time. Any questions? Patrick, I think everyone is okay, and they are geniuses in Terraform. Yeah.
Awesome. So, I guess we've learned something. And it is important that once you come into such a learning, you go out there and try and do it on your own. The video will be up on our YouTube channel, so you can rewatch it and follow the guides that have been presented for us by Marcrine. So Marcrine, thank you so much for that session. The session has been really informative, and we look forward to having you again next time. I hope everybody is okay. Seeing that we don't have any questions, I believe we can call it a wrap. And guys, be ready next week. Next week we'll be back same time with another presentation on a different challenge. So follow us on LinkedIn, CloudForceSky. I dropped some links on the chat, so you can follow us there. And yes, so from us, we say it's Kwaheri for now. Until next week.
Patrick, Mark wants to talk.
Oh, Mark, please do.
Okay. Thank you, Marcrine. Thank you, Patrick, for the amazing session. I just wanted to add a comment of how important it is to learn Terraform. I think this is a game changer for me personally, because I'm tired of the console having to move there every time. Yeah, it's very stressful and annoying, but learning Terraform is going to be a game changer for me. So thank you so much.
Awesome.
Most welcome.
Hillary wanted to talk too.
Yes, Hillary.
Marcrine, thank you for the session. I have a question. Will you share the source code maybe through your GitHub page or something of that sort?
Yeah, I'll share it. I even have an article for that, explaining everything. In fact, let me share it right now.
Okay, thank you.
Someone else wanted to talk. Delphi,
Okay.
I think Delphi.
Thank you very much for the session. And Mark has just added a comment on how is it important to learn Terraform. But I have a concern. Can you just go to start infrastructure as a code without knowing how things are in the console.
Okay. Okay, let me answer that. Or Patrick. Patrick, do you want to answer?
No, just go ahead. Go ahead.
Okay.
It's okay.
Okay. Hey, okay. You have to first you have to learn the basics of AWS. You have to interact with the console. Okay, Janet wants to talk. Maybe she'll answer it better.
Yes, Janet.
Marcrine. So I wanted to add something on that. So it's very good if you understand the console first. Like what Marcrine was doing, she was trying to provision a load balancer. You cannot really start to understand the listeners. You cannot really start to do deployments of the target group if you don't really understand it from the console. It makes it easier when you now shift to infrastructure as code. So I think it is very crucial to first learn how to do these things from the console, then later now simplify everything by using infrastructure as code. Yeah, that's it.
Okay, thank you.
Patrick, back to
Thank you, Janet. Thank you, Janet. So I have shared a link to a channel on YouTube where the guy teaches Terraform from beginner to intermediate. So maybe those guys that are interested to learn more about Terraform, you can go over there. If you have any questions, you can also come ask us, or even go straight to Marcrine. You'll find her on GitHub, LinkedIn. Yes, Lewis.
Sisi kama maguest hatuwezi access chat function.
Oh,
yes, sorry.
Ouch. Sorry. So what I will do, I will share the same every link that we've shared here. Expect it to be on our LinkedIn page. Yeah, you'll find us on LinkedIn. Getting us on LinkedIn is very easy. Just type CloudForceSky. CloudForceSky, then you'll see this logo there. Let me show you the logo. I hope you can still see my screen. Marcrine,
No,
is my screen visible?
No.
Oh.
Yeah.
Just a second. Let me share it just now. Okay, tell me if you can see my screen. This is our logo. Yeah. So when you go to LinkedIn, search for CloudForceSky, you'll get that logo. We will drop all the links there. Yes, we'll drop all the links there. Lewis, thank you for that.
Yeah.
Do we have any other question or any other person that wants to speak, Marcrine?
Anyone who wants to say something, anything? Okay. I think everyone is okay.
Awesome. So thank you again, Marcrine, for that session, and thank you everybody for attending today. We look forward to having you again next week. So from us here at CloudForce, we wish you a good evening and a blessed remainder of your week. Till next time, bye-bye.
Bye.